As we start into section 1.4, you're going to notice here we actually have 5 different objectives we're going to look at. Now, it sounds like a lot of objectives. I'm going to tell you this section's not necessarily too hard. We're going to first determine if a data set has any outliers. This is going to be something new that you are going to learn. You're going to read, construct, and interpret box plots. This is going to be a little bit of new material, but something you have seen before. Third one, understand where percentiles lie in a box plot. This is just really understanding what a box plot is. Number 13, understand how extreme data and outliers impact statistics, such as the measures of center and spread. And the last thing is estimate the 5-number summary for a box plot. It really comes down to focusing on box plots and looking at a mathematical outlier calculation. And let's just get right into it. As usual, we're going to start off with some vocabulary. When we talk about the spread of data, it's how spread out data is. Range is one word that we would use. To figure out the range of the data, what you would do is put the data in increasing order, and then find the difference between the maximum and the minimum. And that is your range. And it's a single number answer. So don't just tell me the range if you had a set of data is like 80 minus 10. Tell me 80 minus 10 is 70. 70 would be that answer if I just had some general data. Quartiles. Just like a dollar is divvied up into 4 quarters, data can be divvied up into 4 quartiles. Quartiles is when you divide an ordered set into 4 subsets of equal size. Okay. You're going to have, when you construct your data and put it into different groups or quarters, you're going to make 3 different quarters, 3 different areas to just separate it. You're going to have the first quartile, the second quartile, and the third quartile. So, for example, let's just pretend that this is a visual picture of the range of your data. When you quarter your data up, you're going to have one group here, another group here, and another group here. Those are the quartiles you're making such that you get 1 quarter, 2 quarters, 3 quarters, and 4 quarters. You get 4 chunks. To do that, I had to make 3 quartiles. I had to make these 3 lines. That's what the quartiles are. So the first quartile, by definition, is going to be what we say is the median of the data below the median. So what you do, again, if you take this picture up here, this right here is the median of my data. That's the middle. If I take that lower half of my data and cut it in half, I get this first quartile. Okay. The second quartile is just another word for the median of the data. Typically, they don't actually call it the second quartile. They will refer to it as the median. And again, the median just sits here right smack dab in the middle. Now, the third quartile is this little chunk right here. So what they do for the third quartile is they find the median of the upper half of the data. So it's going to be the data above the median. All right, another word is called the interquartile range. If you think about when we said range up here, to find the range, we do the difference between the maximum and the minimum. To find the interquartile range, you find the difference between the 2 largest quartiles. So what you do is you take quartile 3 minus quartile 1, and you get a distinct answer. That is called the interquartile range. It tends to be abbreviated with the letters IQR. So if they ask for the IQR, that's interquartile range. Okay, the 5-number summary. The 5-number summary is basically just giving you the spread of what we talked about. So the 5-number summary includes this. It is the minimum of your data. It's quartile 1. It's the median, or quartile 2. It's quartile 3. And we want a 5-number summary, so we're missing the 5th piece, which is the maximum. If you have a 5-number summary, you can take that 5-number summary and actually make a picture of it. Making a picture of the 5-number summary gets you this box plot right there. Let me show you how this box plot was comprised. Assume the data in front of you is our test scores on a 100-point test. They're already put in increasing order. What they want us to do is find the 5-number summary. Okay, the minimum is incredibly easy. It's right there. That's our min. Okay, The maximum is right here. So we have 2 of the 5 from the 5-number summary. Now the median is a piece of data smack dab in the middle. So let's see, if we get rid of 1, 2, 3, 4 on this side, I'm going to go up 4 here. Got to keep going, so I'm going to go 2 more on this side and 2 more on this side, 1 more and 1 more. There's not one right smack dab in the middle. How do you find the median of your data set? It's the number right in the middle. There is not one right in the middle. So how do you find that median? This here is the median. To find it when there's not a specific number, you just take the 2 numbers you're left with and you find their average. So 77 plus 77 divided by 2 is still going to be 77. Therefore, the median of this data set is 77. Okay, now let's find quartile 1 and quartile 3. Quartile 1 says it's the median of the lower half of the data. Well, when 77 is both here, just split it. Give each one one of them. That's the lower part of the data. What's the median of that? Well, let's find the middle number. I'm going to cross off 3 here. I'm going to cross off 1, 2, 3 here. There it is. That's quartile 1. Okay, go to the upper half of the data. This is the upper half of my data. I'm going to do the same thing. I'm going to cross off 1, 2, 3 from that direction, 1, 2, 3 at that. That is quartile 3. Now, what they did to make this box plot you see in front of you, it's very easy. Notice there's no labels, though. They didn't put Q1, Q2, or Q3. It's implied, and you don't actually ever write the Qs. This here is the median. What you do, the 77 is the median, so you draw this little straight vertical line. Quartile 1's at 71. That was this. Quartile 3 was at 83. That was this. What they then did is just made a box. Okay. Now, this is called a box plot, or sometimes you'll hear it referenced to as a box and whisker plot. The whisker is the minimum. So 61 is the min, 94 is the max. You connect those and you have for yourself the box plot, or the box and whisker. Now, remember, a box plot puts everything in quartiles, or it groups your data. So what you are seeing here, this is where one group of 25 sits. Here's another group. Here's another group. And here's another group of data. We should realize that the median's right here. The median is the middle. So this is the 50th percent. The 50th percent sits there. Well, this is the maximum. That's the 100th percent. This is the minimum. That's the 0, or really at least something greater than 0%. So what happens in between 0 and 50? Well, this is the median. That's the 25th percentile. Okay. Between 50 and 100 is the 75th percentile. So what we've just done is this. We have just discovered that if I were to look at all the data that makes up this line from 0 to 25%, that's where 25% of the data sits. We'll look at the other end. From 75 to 100%, that's another 25% chunk of data. So here's 25% of the data, here's 25% of the data. Well, between 25 and 50%, that's another 25%. Okay? Between 50 and 75%, that's another 25% of the data. If you add up all 4 of these little red arcs I just drew here, that's 100% of the data. So the box plot is a visual representation of how your data is chunked into the 25% groups. And you have to be able to see how those groups are interpreted. Now, I probably did more detail on that first slide in showing you how to make a box plot. Let me actually give you the thought process in doing it, and then we'll have you try one on your own and then move on to something else. Now, constructing a box plot, it's just a visual representation of the 5-number summary. Now, to draw a box plot, you draw using a number line as a guide, which we did on that last slide. And it's often used to compare data sets. We use box plots. Typically, we like to have 2 box plots next to each other so we can compare 2 different data sets. That's the best part to do it. How do you go about doing it? Here's the first suggested step. Draw a number line and include the lowest and the highest values. Number 2, Draw a box identifying Q1 and Q3. 3. Draw a segment to represent Q2, which is really the word for median. And then 4, use the median and the minimum and the maximum to draw the whiskers or those lines. So let's go ahead and look at some data real quickly on the next slide and construct a quick box plot and then move on. Here we have this data here are the ages of the best actor Oscar winners from 1997 to 2006. This is factual data. They want us to give them a 5-number summary of the ages and then draw the box plot. Well, what I'm going to have you do is pause the video, and I want you to go ahead and by hand figure out what the 5-number summary pieces of data are. And then turn the video back on and you'll see it pop on the screen and you can see if you are correct. So go ahead, pause the video. I want you to find the minimum, the maximum, Q1, Q3, and the median. Okay, this is what you should have gotten for the 5-number summary. Again, just take a look at the data above. If you didn't get it, double check what you have there. Now, next step, pause this video one more time, and I want you to use this pink line down here as the line that you'd put your number line on and then sketch your box plot. So pause the video and see if you can sketch this box plot appropriately. Go ahead. Okay, there's what your box plot should look like, something similar to it. One thing, it should not be drawn on top of that number line. You never draw it on top of the number line, and you don't label anything. As long as your number line is scaled out appropriately, and notice all my scales, I count by 5s, they're equally balanced out, you should be able to read the data from that. So let's move on. You know, here's another set of data. We're not going to go through the details, but I, in class, will show you how to construct a box plot using the graphing calculators. We'll probably just go back and use the data that we did on the last slide, but you could go ahead and do this, and we'll talk about that in class. So just hold tight for this slide. Okay, we have 2 more things we want to talk about, and that's the end of the notes. This is the last real mathematical component, and it's finding outliers. If you hear the word outlier, you might want to, what does it mean to be an outlier? If you're an outlier in a group, you may not fit in. You lie on the outside. So it's something that doesn't really fit into the norm as an outlier. In our cases, because we're talking about box plots or numbers, it's a numerical value. What number is outside of the normal data that we've collected? And there is a test that we can do. It's called the Outlier Test. So let's talk about this first. Outliers are very important in statistics in that they have a significant impact on the actual mean of your data. Okay? The median and the mode don't really get impacted that much by an outlier. But if you have, let's say I collect data about your age, and one of your parents happened to join us for class today, most of the ages I would collect would be 15, 16, and 17. And then what if I had someone who was 45 years old in that data set? That's going to skew my mean. That one older person will skew the average age in this classroom if I count a parent. So you want to be cautious and try to figure out, is a piece of data in my set an outlier and should I take it out? The second point, they may be important though because they represent a special class. So do you really take them out of your data? You need to determine in your analysis if you do have an outlier, if it should stay there or not, and footnote that. Okay, here's the test, and let me show you what we're going to do. I'll walk you through the steps. The first step of the outlier test is to find the value of the IQR. So you need to take Q3 minus Q1. Once you have that, you go to step 2. You take your IQR value and you times it by 1.5. Once you have this value, this 1.5 times the IQR, what you do is you take that value there and you add it to Q3. Any number larger than that is considered an outlier. Now on the other side, you're going to go to Q1. So we take that 1.5 times the IQR, but this time we subtract it from Q1. And any number smaller than that is considered an outlier. And let me show you a quick visual representation. I think if you kind of look at it in terms of a box plot, it's easier to see it. Okay. Right now, Q1 sits right here, and Q3 sits right here. What they're doing is they're taking this multiplier, this 1.5 times the IQR, and they're adding it to Q3. So if they add that to Q3, what happens is this thing kind of, if you add to it, gets pushed out. goes out a little bit further. They're saying that's the maximum amount you can go out. Anything above that would be considered an outlier, anything in this range. On the flip side, they're going to take that multiplier, which is 1.5 times the IQR. They're going to go to Q1 this time. And they're going to take that Q1 and push it back this way, so you have to subtract it. If you subtract it, that's how far you can go. Anything smaller than that would be considered an outlier. So that's how you actually do the outlier test. Now, you don't come in here and actually reconstruct the box plot, but that's just a way for you to visualize kind of what's this stuff that's sitting on the outside. This is all the anything too small, and this is anything too big sitting out there. So what I want to do is let's go to the next slide and actually do an outlier test and see what we can find. Now, this is the only example we're going to do on computing IQRs. You have to know how to do this on a test, and you have to be able to show the work. So let's get your questions answered now. Here's the deal. Take a look at the data here in the table, by the way, or the graph. It says it's the payroll of Major League Baseball teams on opening day in 2007. It's in millions of dollars, okay, and it's frequency. And we have a histogram here, and we have the raw data here. Now, let's read above. They've actually done the 5-number summary for us and gave us the data. It says here it's a 5-number summary in millions of dollars. So the minimum is $24 million. That means there's one team that paid a total of $24 million for all the salaries on their team in 2007. Okay. The maximum is $190, by the way. One team paid that much, probably the Yankees. Quartile 1's right here, the median, and then quartile 3. They want us to use the 1.5 IQR to determine if there's any outliers. If there are, identify them. So the test says, remember, I'm going to take Q3 and add to that 1.5 times the IQR. Now, any number larger than that is an outlier. On the flip side, I have to then take Q1, though, and subtract from it 1.5 times the IQR. Any number smaller than that is an outlier. So you kind of have to do two tests to do this, and you have to show me that you're testing both sides of the data, even if the answer is there's no outliers at all. So I'm going to start by just doing the IQR. IQR is Q3 minus Q1. Order matters in subtraction. So it's going to be 100 minus 62, which is 38. Okay, now I have to take 1.5 times that IQR. So take 1.5 times 38, and we're going to get 57. Okay, that is this multiplier. So what I'm going to do now is I'm going to say take Q3, and I'm going to take Q3 as 100. So Q3, and I'm going to add to it the 1.5 times the IQR. So that's 100 plus 57. That is as high as I can go. Any team paying more than $157 million is considered an outlier. If we look at the raw data, that would mean the team paying $190,000 is an outlier. Okay, that's the high end of the test. Now I have to do the low end, so I have to look at Q1. Again, think of it if you had a box plot. If we had a box plot, we're talking about pushing Q3 up as high as we can. This is as high as Q3 can go, even though we don't change it. Now Q1's got to be pushed down, so we have to subtract. So I come in here and take Q1, and I minus 1.5 times the IQR. Okay, fine, Q1 is 62, minus 57. That's going to give me a difference of 5. Is there a team paying anything smaller than $5 million? There is none. Okay, so there's no outliers on the bottom half. But I'm going to tell you, if you do not show me this test, this testing both ends of it on the test, you're not going to get full credit. Okay, answer the question. Identify any teams. The $190 million team is considered an outlier in our data set. That's how you do the outlier test. Anyone getting paid within this range between $5 million and $157 million is okay. Anything outside of it is not. Now, this slide I actually think is pretty interesting. I'm going to have you do some matching and figure out which histogram goes with which box plot. So here we go. Give information about the shape and the distribution of values. So a histogram and a box plot, they do give you an idea about the shape. Look at these. I'm going to have you pause the video and figure out which box plot goes with which histogram if you had to match them up. So pause the video and see if you can match up which ones go together. We have a histogram here. This is skewed to the right, skewed to the left, perfectly symmetric. Go ahead and pause it and see if you can do it. Did you come up and match them this way? Now, the easiest one to look at first is probably the one that's perfectly symmetric. If it's perfectly symmetric, there's some nice balance. We see here everything is pretty much kind of balanced and equal out. Histogram B, this is skewed to the left. More of this data is on the right-hand side of the graph. So where do you see more of the data for this graph? Right here, you guys, remember each chunk is 25%. This right here, no, sorry, let me fix that. This little chunk right here, that's 25% of the graph. Here's another 25% of the graph in that chunk. Here's another 25%, and then another 25% of the graph. You have, if you look at this and kind of cut it in half, this graph right here, almost if you cut it in half down the middle, you have 75% of the graph sitting to the right-hand side. That's what you have here in this histogram. Okay. Conversely, this histogram A over here, more of the data is to the left-hand side. Well, you have over 75% of the graph to the left-hand side of this graph, so that's why it matches up accordingly. Now, in this homework assignment, again, come to class prepared. Let's do the entrance card. If you make the entrance card, that is the modified assignment. This is going to be the general assignment. Again, I may adjust it. Let's wait to see what I do in class. Good luck on your entrance card, and let me know what questions you have.